video we're going to talk about adding, subtracting, and multiplying polynomials. The first thing we want to talk about though are like terms. Okay, like terms are what you're going to be focusing on, if I can spell there, when you're adding and subtracting polynomials. Alright, so like terms, what they are, it means they have the same variable with the same exponent, or both terms don't have variables at all. Neither one have variables. So for example, if I have the number 3 and then I have plus 5, 3 is a term, 5 is a term. The reason that those are two separate terms are because they're separated by a plus or minus sign. Okay? And if you'll notice with the 3, there's no variable. Notice with this horrible looking 5, there's also no variable, which means these are both like terms, and you can add them together. 5 plus 3 is 8. Okay, so let's look at some more like terms. Let's say we have 2x and we have 5x. So again, the 2x, because it has an x with the exponent of 1, and the 5 has an x with an exponent of 1, these two terms are like terms. So I could add or subtract these two terms. So if I'm given a polynomial that looks something like this, what I want to do first is look to see if I have any like terms that I can actually combine together. So I have a 5x to the 4th. So what I'm looking for here is, do any of my other terms have x to the 4th power? Alright, so let's go to our next term, 6x to the 3rd. Okay, well that has an exponent of 3, therefore these two are not like terms. Let's go to the next one, 2x to the 4th. Well, 2 has x to the 4th power, which means this minus 2x to the 4th and 5x to the 4th are like terms. I can combine those. But let's go ahead and see if we have any more. 3x, x does not have an exponent of 4, therefore 3x is not a like term to the x to the 4th powers. And there are no more sets. This is x to the 3rd, which is different from just x or x to the 1st. So I'm done with the finding like terms. Now what I want to do to finish simplifying this problem is to actually combine the like terms. So always go with the sign that is in front of the term. So here I have 5x to the 4th. Since there is no sign, we assume it's positive. Back here with this 2x to the 4th, there's a minus sign in front of it, therefore it's a negative value. So I'm going to say 5x to the 4th minus 2x to the 4th. That's going to leave me with 3x to the 4th. Then I'm going to bring down the rest of my terms, my remaining terms, and I'm going to write them in descending order based off of their exponents. So next is going to be 6x to the 3rd plus 3x. Okay, and when I said descending order based off of their exponents, I'm talking about it should be going down, getting smaller. So we have 4, 3, and then 1. That's descending. Okay, so that's your basics with like terms. So hopefully this was a good refresher for you. So let's actually look at adding and subtracting with polynomials. Okay. So when adding, most of the time you're going to be given a couple sets of parentheses. So let's say in one set of parentheses I have 2y minus 5y to the 3rd, close parentheses, plus 3y plus 6y squared. Okay, now, because these are grouped in parentheses, we need to treat them sort of separately. But the cool thing with addition is that you really don't have to do a lot of stuff. You just have to add like terms together, and you can kind of ignore the parentheses, okay? But that only works right now for addition. When we start doing subtraction, I'll show you there's a little trick to make sure that you do your subtraction correctly. So with addition, again, it's pretty simple. So we start here finding like terms. I have a 2y, that's y to the third. Here's a 3y, that's y squared. So the 2y and the 3y are like terms. Again, go with the sign in front of the 3y. Again, since we're adding here, I can just kind of ignore the parentheses. So this 3y is positive, 2y is positive. That's going to give me 5y. Okay, I'm going to go ahead and mark those out to show me that I'm done. Next, I have minus 5y to the third, and over here I have a 6y squared. They are not like terms because they have different exponents. Therefore, I'm just going to bring them down. Now, if you remember just a minute ago, I told you to write your polynomial so they're in the exponents are in descending order. So right now, this is just a little bit of mathematics grammar. Technically, this answer and solution is correct. However, since we are honors math students, we want to get our math grammar correct as well. So we're going to take the value with the highest exponent, and we're going to write it first. And then we're going to go in descending order. Okay, so this is how your solution should be written. Let's look at subtraction. Okay, because there is a minus sign in between the two sets of parentheses, you're going to have to do a little trick. Now this is how I do my subtraction problems. It makes life just a little bit easier. It eliminates a whole lot of areas where you can make very simple mistakes with your signs. So here's what you do. I'm going to change my colors. Since I see the subtraction sign in between the parentheses, what I'm going to do is I'm going to change this to a plus, and then I'm going to change the signs, everything afterwards. Sorry about that little thing there. Oops. Okay, so all I did was I changed the minus sign to a plus, and I changed the sign for the terms in the second set of parentheses. Now here's the mathematics behind that. What I'm doing is I am essentially multiplying by -1, okay? And what I've done is I've just multiplied by -1 so that when I combine my like terms, I've got the right signs going on in this second set of parentheses. A lot of times students don't distribute that negative to the second term or the more than one term in a set of parentheses. So it's real important to just do this little trick first and then combine like terms. And you've got an addition problem, which makes life just a little bit easier. So now I have 4x plus -6x, which gives me -2x. And I have 2y plus 3y now, and that's going to give me plus 5y. Now since these are different variables, but they have the same exponent, writing your solution in this order right here is perfectly okay.